Neuroendocrinology is the field which looks at the way in which the environment talks to the brain and the brain talks to the body and the body feeds back and talks back to the brain. In other words, maintaining homeostasis for all the major systems. And this includes temperature control, electrolytes, water, thyroid function, adrenal, reproduction, growth. So it impinges on every area of health and disease in humans. And I started off in the University of Zimbabwe. I was quite inspired by the concept and the determination to work out mechanisms which controlled health and disease. I was fascinated by biological diversity and how animals work and how the environment talks to animals and how they respond. My first job was to go to Zambia, where I worked in cattle reproduction. And I showed that natural estrogens in grasses were responsible for infertility in the cattle. I then went for further study and did a master's in London, followed by a PhD in Liverpool. I then was offered a job at the University of Cape Town. Most of the signaling in neuroendocrinology is by small molecules in the brain called peptides. And there are thousands of these. We've hardly explored them really in any depth. And they are all fine-tuned to talk to each other through receptors to balance everything. And that was the beginning of neuroendocrinology, the Oppenheimer Fellowship. It's undoubtedly considered as being one of the most prestigious awards in South Africa. The award was made for a new area that I'd started, which was receptors can become mutated and cause disease. The mutant receptors remained inside the cell. And what we discovered is you could rescue these receptors with small molecules which could penetrate the cell and refold it so that it was now active and could go to the surface. These receptors constitute something like 800 in the human genome. So there's a vast field of disease and potential therapy that we can explore. So about half the drugs that are in the market today are actually those targeting these class of receptors. And the beauty of that is that the pharmaceutical industry has made thousands and thousands of small molecules targeted for these receptors. So for us to try and rescue it, we look at the published small molecules, and we can then co-opt those and use them to rescue these receptors.